Hi, welcome to the part 9 of the Capsule video series on momentum and impulse. We started answering questions in the last video to help us better understand the subject. We will solve yet another question in this video. Object P of mass 500 kg moving east collides head-on with object Q of mass 250 kg traveling at a constant velocity of 5 meters per second west before the collision. The graph shows how the momentum of object P changed with time just before and just after the collision. In the first part of the question, we must calculate the magnitude of the velocity of object P just before the collision. On the graph, we can see that between the time intervals of 10.1 and 10.2 seconds, the momentum of object P changed dramatically. The collision occurs within this period of time. The momentum of object P is 15,000 kg per second before the collision. As usual, we begin by writing the equation to find the solution. Mass times the object's velocity equals momentum. 15,000 is equal to 500 times v. Prior to the collision, P was moving at a velocity of 30 meters per second. There is no need to provide direction in our answer because we are only asked to calculate the magnitude of the velocity. The second part of the question asks us to determine object Q's velocity immediately after the collision. According to the conservation of the linear momentum, the total linear momentums before and after the collision are equal. We had two objects with individual momentums before the collision. We can see that even after the collision, these two objects are traveling separately because the question asks us to determine the velocity of object Q. P has an initial momentum of 15,000, while Q has an initial momentum equal to its mass times velocity, 250 multiplied by a negative 5. The direction that we consider as positive is not specified. How then can we know that Q's starting velocity is negative? According to the question, object P was initially traveling east, and its initial momentum has a positive value on the graph. This shows that east has already been selected as the positive direction in the question. Westward direction will be considered as negative in this situation. Following the collision, object P's momentum is 7,000 and object Q's momentum is 250 times its final velocity. It is equal to 27 meters per second. Positive result indicates that following the impact, object Q is traveling east. The magnitude of the net average force acting on object P during the collision must be calculated for the final part of this question. Because the net force applied on the objects during the collision does not remain constant, the phrase net average force was used instead of just net force. At the high school level, we are only considering the average value of the net force to make things simple. The second law of motion states that the net force exerted on an object is equal to the rate of change of momentum. Delta is the final value minus the initial value of any quantity. Therefore, the equation can be expressed as final momentum minus starting momentum over final time minus initial time. The collision occurred between the seconds 10.1 and 10.2, where 10.1 is the starting time and 10.2 is the ending one. The momentum of P is 7,000 at 10.2 seconds and 15,000 at 10.1 seconds. As a result, the net force is equal to minus 80,000 kg per second. In the case of a negative answer, we always write the positive value and direction of any vector quantity. Thus, the net force is equal to 80,000 kg per second. despite the fact that we are not asked to indicate the direction and the question only asks for the force's magnitude. Determining it will be helpful for learning purposes. Because the net force we calculated is negative, it is acting west. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.